Today we're going to be talking about how to find the domain of a vector function, and in this particular problem we've been given the function r of t, where r is the vector, but r of t is equal to the square root of 4 minus t squared e to the negative 3t, natural log or ln of the quantity t plus 1. Now we said that r is the vector and this function is r of t. This equation is written as a vector function. T here is the parameter, and each of these three values, each of these three components, are basically parametric equations. Now how are we going to find the domain of a vector function? Well, conveniently all we need to do is find the domain of each one of these separately and then combine our answers to see which values are limiting our domain. So first we want to talk about the domain of the square root of 4 minus t squared. Well, we know that the value under a square root sign has to be positive in order for us to find a real answer. So what we want to do is say that 4 minus t squared has to be greater than or equal to 0 in order for this to give us back a real answer. Now we can solve this inequality for t. The way that we're going to do it is by adding t squared to both sides. We'll get 4 greater than or equal to t squared. When we take the square root of both sides to get t on its own, what that's going to do is give us a positive 2 over here on the left because the square root of 4 is positive 2. But because we're taking the square root here, we also have to add the other side like this and add our negative 2 value, because obviously we could get a negative 2 here, but we say that t is greater than or equal to negative 2 and less than or equal to positive 2. So basically t has to be between negative 2 and positive 2 in order to be within the domain of this first component. Now let's take a look at our second component, e to the negative 3t. Well, really, we can plug in any value to this function for t. If we plug in a negative value, we'll get negative 3 times some negative number. That'll give us e to a positive number. That's no problem. If we plug in 0 here, we'll get negative 3 times 0, which is just 0. E to the 0 is 1. Again, that's no problem there. And if we plug in some positive number, we'll get negative 3 times a positive number, which will give us a negative number. And again, e to a negative number gives us no problem. We can get a real answer back in any of those cases. So this doesn't really limit our domain at all. Well, what about natural log of quantity t plus 1? Well, remember that when we're dealing with natural log or ln, the value inside the natural log here has to be greater than 0 in order to return a real number answer. If we take the natural log of 0, we can't get a real number answer. If we take natural log of a negative number, we can't get a real number answer. So what we really want is this value inside the natural log here, t plus 1, we want that to be greater than 0. In order to solve this inequality for t, we just need to subtract 1 from both sides, and we see that we get t is greater than negative 1. Now don't forget, we don't want to say greater than or equal here, because if we said greater than or equal, we could end up with natural log of 0, and remember that natural log of 0 does not give us a real number answer. So we want to say just greater than 0, t is greater than negative 1. Now all we have to do, since we've looked at the domain of each of these separately, is put our domains together. We can see here from our first inequality, t greater than or equal to negative 2 and less than or equal to positive 2, if we draw a number line here that defines the domain of t, we can say here negative 2, 0, positive 2. So for this first inequality, t is defined everywhere between negative 2 and positive 2, including the endpoints negative 2 and positive 2. Those count as well. But then this t greater than negative 1 comes along, and that tells us that our domain is only defined here, essentially, if this was about negative 1, from negative 1 to positive 2, like this. So because this further limits our domain, we can't include this part of the domain right here between negative 1 and negative 2. So what that tells us is that our domain is from negative 1 to positive 2. All we need to indicate now in our answer is whether or not these endpoints are included. Well, we already talked about positive 2. Positive 2 is going to be included because we have this less than or equal to sign, this equal to sign right here. So we know 2 is going to be included, and therefore we draw a hard square bracket like this. -1 we know is not going to be included. This endpoint right here is not included because remember, if we set t equal to -1, we'd end up here with natural log of 0, which would give us a non-real answer. So we don't want to include -1, which means we draw a soft parentheses here by the -1. This is our domain for the parameter t, and that's how you find the domain of a vector function.